Welcome! In this video, we'll be looking at the examples from Lesson 2 in Module 2 for Grade 7. We'll be modeling addition on the number line and taking a look at some of the results we get. In Example 1, we're going to complete the steps A through F to find the sum of -2 plus 3. And we're going to model an equation using straight arrows called vectors on the number line. To start, we're going to place the tail of the arrow on 0. Whenever we start an equation, we're going to start at 0. Our first number is -2, so we're going to draw the arrow 2 units to the left of 0 and stop at -2. The direction of the arrow is to the left, since you're counting down from 0. This is what the arrow would look like. We're going to start the next arrow at the end of the first arrow, or at -2, and draw the second arrow 3 units to the right, since we're counting up from -2. Remember, when we go right, we count up. This is what the arrow would look like from there. We stop at 1, because counting from -2 3 times, 1, 2, 3, gives us 1. And then we're going to draw a circle around the number that the second arrow ends at to indicate the ending value. This is the sum of -2 plus 3. In the next example, we're going to do the same thing, only we're going to change the order of our sum. This time we're going to do 3 plus -2. We're going to start the tail of our arrow on 0 again, and we're going to go 3 units to the right, because 3 is positive, and stop at 3. Here's what the arrow would look like. We're going to start our next arrow at 3, and then we're going to go 2 units to the left, stopping at 1. And again, we're going to circle the answer to help us see where it ended up. As you can see, whether we did -2 plus 3 or 3 plus -2, we ended up at the same answer, 1. So the question is, does order matter when adding numbers? Why or why not? But the sum of -2 and 3 and the sum of 3 and -2 are the same. They both equal 1. The order does not matter when adding numbers because addition is commutative. As long as we take the signs with our numbers, we can change the order in any manner we choose with addition. Let's take a look at another example. We're going to talk about expressing absolute value as the length of the arrow. As a reminder, the absolute value of a number is how far the number is from 0. So if we want to find the absolute value for -2, that's 2. And so the length of our arrow is 2 units long. If we use the same process for 3, we can see that an arrow that is 3 units long to the right looks like this. The absolute value of a number tells us how long the arrow is. Since the absolute value of 3 is 3, the arrow is 3 units long. If we want to describe how the absolute value helps you represent -10 on a number line, we need to know the absolute value of -10. The absolute value of -10 is 10. So that means the arrow on the number line has to be 10 units long. All right, on to example 3. Here we're going to have a number line model, and we're going to be finding the sum of 3 numbers. In this model, the first arrow starts at 0 and is 5 units long. The second arrow is 2 units long to the left, and the third arrow is 3 units long to the right. If we wanted to write an equation to express the sum, we would have 5 plus -2 plus 3, and the sum is 6 because that's where the last arrow ends. If we were to choose 3 cards that represent this model, the 3 cards would be 5, -2, and 3, since that's the length of each arrow on the diagram. The question C says, in what way does this model differ from the ones we used in Lesson 1? Well, in Lesson 1, we were using hops. In this lesson, we're using straight arrows, called vectors, that represent the length of the number. Each of those methods, whether we're using hops or straight vectors, show us the same total movement. Question D asks, can you make a connection between the sum of 6 and where the third arrow ends on the number line? 5 plus negative 2 plus 3 equals 6, and on the number line, the last arrow ends at 6. So the final position of the third arrow is 6. This means that the sum of 5 plus negative 2 plus 3 is 6. Question E asks, would the sum change if we changed the order? Now remember, in our previous two examples, we changed the order and got the same sum. So if we change the order to negative 2, 3, and 5, negative 2 plus 3 plus 5, the sum doesn't change at all. That's because addition is commutative. The order does not matter. Would the diagram change? Yes, it would. And here's what it would look like. First, we would start at 0, and we would go 2 units to the left. That would represent negative 2. And then starting at negative 2, we would go 3 units to the right, representing adding 3 to it. And then, from 1, we would add 5 to represent the third add-in. We would still end up at 6, just like before, but our diagram would look different. Okay, make sure you have all the information down for these notes, and we'll move on to Lesson 3 in the next video.